On section 10.4, we're doing a one-way analysis of variance. It's abbreviated ANOVA for analysis of variance. And this is used a good bit. Anytime you're wanting to compare the means from 3 or more populations to see if any of them are significantly different, you use the ANOVA test. So let's go ahead and do this. Again, 3 or more use the ANOVA test, and they have to be different groups. No before and after type of thing or anything like that. Now, if you only have 2 means and you're comparing them, that takes us back to section 8.1 where you're doing the unpaired t-test. If you have 3 or more, then you'll be needing to run the ANOVA test. It says the table below shows the annual amount spent on reading for a random sample of American consumers from 4 regions. Check to see if the mean amount of money spent on reading in any of the 4 regions is significantly different than the others, and summarize the most significant alpha level. We have to assume that the amount spent on reading at each location is normally distributed, since we don't have that large of a sample here at any location. So what I did is I went to the data sheet on the Excel sheet, and I copied from the last sheet the data called on the data sheet, this data for section 10.4. Then I went back to the ANOVA sheet here, and I went to where we can put in our data, and this can handle up to 10 groups, so that's a lot of groups right there. And I just went right here and did a paste special as values and got my data in there. Now once you get your data in there, it calculates a lot of things over here that it's going to copy and paste special over here for you. But before you do that, before you click that button to copy the values, put in the number of groups right here that you have. That's critical. So we have 4 groups, so you put 4 right there, and then you click the button and it copies all your information over. So here's the mean of each of those groups, and while it looks like the average amount spent in reading in region 4 is significantly greater than the amount in region 3, that's not the case, because if we look down here at the p-value, the p-value is 0.215, and that's greater than any alpha level you would use, including even the 0.1 alpha level. You wouldn't reject that null hypothesis. And we can see do not reject. That p-value is huge. And this uses the F distribution. And the F distribution is not a symmetric curve. It looks like this. And here's the rejection region, and here's your test statistic, and it didn't fall in the test in the rejection region. So your summary for this problem would be, at any alpha level, I was unable to show that the average amount spent on reading at any of the locations is significantly different than any of the other locations. Now you may have noticed we used the F test rather than a Z or a T or even a chi-square, and the Excel automatically calculates the critical F value and the F test statistics, but you may need to report these sometimes. Let's say if you're writing a paper or something like that. Well, the F test statistic is reported by typing the letter F, italic, then the number of groups minus 1, comma, the number of sampled minus the number of groups. So for the previous example, there was 4 groups and there was 27 people sampled. So the F test statistic we reported as F parentheses, since there was 4 groups, 4 minus 1 is 3, comma, the number of sampled, which is 27, minus the number of groups, 27 minus 4 is 23. And what was that test statistic? I believe it was 1.61, and the p-value was greater than 0.1. And we can see that here if we check our test statistic here is about 1.61 rounded to the nearest hundredth, and our p-value was greater than 0.1. Now the critical F value that determines what your rejection region, well, you'd have to, Excel automatically gives that to you. Right here is your critical F value. Let's see, critical F value 2.33. Now, if you didn't have Excel, then you'd have to look this up on an F table. And I have part of an F table here. And F tables aren't in this book, but they would, because there's so many, you'd have to have an F table for every alpha level. And you have the numerator degrees of freedom, which is your number of groups minus 1, which is 3. And then you have your denominator degrees of freedom here, which is your number of people sampled minus your number of groups, which I believe was 23 is what we're looking for there. And so since we don't have 23 listed on this table, the best we can do is this one at 20, and we get 2.38. So that's all you can do when you use tables is get the approximate critical value of 2.38. The actual critical value is 2.338. Not much difference, but the Excel one has the exact value.